The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm Geologist Philip Ong, here with Mr. Dane DuPont from HVERI, the Hawaiian Volcano Education and Resilience Institute. We're here on Hawaiian Volcano Tracker, on Hawaiian Tracker, Facebook, YouTube, Instagram, and spreading from there. Today is Thursday, June 6th, 2024. We have an eruption happen this past week. We were live with you guys on Monday when it happened. We're back for our weekly summary of all that activity and talk story here. So how are you doing today, Dane?
Doing good. You know, start of the week was a little bit busy. Up early that morning and kept up with the eruption while it was going, at least, and seemed to back off pretty quickly and kind of got back into the groove of things again later in the week into today.
Yeah, for sure. So I'm sure we have lots to talk about where we don't have anything out of the usual lineup from past talks or anything like that, past events. We're going to focus exclusively on the Southwest Rift eruption of 2024 today. And as usual, have some discussion of some questions as we go through, look at the signals and all of that, all the reports from the USGS HVO. So before we get into it, anything, you'll be leading discussion on chat. Thanks for that, Dane. Taking questions, which you're welcome to jump in as you like or towards the end, however is appropriate.
Yeah, we'll see if anybody puts some questions in chat, and we'll see what point we can work them in at.
All right, sounds good. So then without further ado, let's get into our regularly scheduled program here, starting with our Hawaiian volcano summary. So in our Hawaiian volcano summary this week, Kilauea had an 8.5-hour eruption on a southwest rift on Monday. The eruption began at 12:30 in the morning and ended by 9 a.m. as far as lava exiting the ground. Lava flows were still moving slowly until about noon on that day, but officially it's being called an 8.5-hour eruption by the USGS HVO. This is some of the footage of that initial fissure, which opened in 4 segments and put out a fairly small pad of lava, about 90 acres. In total, about 0.1 million cubic meters, 100,000 cubic meters. So that's a lot smaller than recent eruptions, and it was a lot briefer as well. And furthermore, there has been ground cracking detected downrift of this area, so it seems likely that magma was on its way past this eruption site, and much of the work was done underground as magma intruded downrift, and a little bit of it was able to leak out through the area that had been cracked previously in the intrusion in late January of this year. So for now, the eruption is being called paused, but also being said to be highly unlikely to resume. And we can look at that with the USGS report here, which describes just that. One thing that was happening was ongoing tremor and gas being emitted from the vents, as well as glow incandescence. And that has been decreasing steadily since the eruption on Monday. So at present, there are still above average gas emissions coming from the site, and VOG is impacting the island fairly widely. But near the source, things are fairly wound down. The map of the eruption looks as such. There's 4 fissure segments and a very small pad of lava. The eruption occurred very near the 1974 fissures, but with a much smaller volume of output and area covered. Looking at what's happening overnight, this is a time lapse from the S1 camera. It was deployed after the eruption was waning. So what you're seeing is the last 3 nights of glow from this view. So I'll play it again. There is the first night of glow, the second night's a little bit less, and the third night is even less than that. So that's the overall decline of the gas and the glow from the S1 camera. Also on a S2 camera, slightly different point of view, but the similar pattern there. And one last one that actually was positioned before the eruption began up on Mauna Loa that catches the beginning of the eruption and the glow from the very start. There it starts, but it's not nearly as close there. You can see there's a second night, and here comes the third night. Still glow visible from a fair distance up near 6,000–7,000 feet on Mauna Loa. So this last one I'll play one more time and just zoom it in and see that sequence a little more closely, because that's been the main impact to people. There's been the gas billowing from this fissure system and dispersing around the island. So that was the summary of the eruption. At present, we can look at the Sandhill ground tilt meter, and the line in greens is looking at that South Caldera area. This signal in here is all the adjustments and propagation of the magma into the eruption site. And since the adjustment here, what you can see is it's actually resumed inflating at a fairly high rate. So the area that was tapped for this eruption is recharging fairly quickly in the South Caldera, whereas it also is recovering a little less quickly in the main caldera by Halemaʻumaʻu. So the South Caldera is still inflating and expanding, while at the summit, we're seeing a little bit more contraction. That's it on Kilauea. Mauna Loa has not seen any effect. Earthquakes are still at a very low rate at the summit and beneath the upper elevation flanks. And that's our Hawaiian volcano summary for this week. Okay, so with that, we'll turn to our volcanic hazards, which is the gas. So looking closely first at the areas within a national park. Eruption site's 2.5 miles outside the main caldera in this direction, more or less in there. And the wind direction is usually as such, so most of the time that gas is blowing away from the main visitor areas in the national park. Still, they're all in green at present, even down in the south part of the island and in Kona, everything in green. And looking at the charts, historically, they've been in a green for much of the time, with occasional, here's the steam vents area showing a spike in SO2 early this morning. So there is occasional gas blowing through. If you are visiting the national park, just follow their instructions and signage as to dealing with the gas. We also have the VOG measurement and prediction project, VMAP from UH Manoa, and their forecast is updated now with the 5,500 tons per day emission rate. That was true 2 days ago. So the USGS has reported the rates are lower today, but we don't have a number yet. So for now, this is the best we can approximate, with our source being a little line down here that's been put in as a feature on this map right there. And then this is using the weather model to show the dispersion of that gas over the next period of time here. Let me speed it up a little bit. So if I zoom it out, you can see that there is some effect that maybe is occasionally wrapping to some other parts of the islands earlier in a sequence especially, but as time moves forward, that largely clears out and it ends up being focused here in Hawaii Island itself. You can see at the start of the frame, there is VOG trace everywhere. And so really anywhere on an island could have experienced these levels. You see it moving north to Hamakua, clearly on the west side, clearly over in Kohala area, and Puna as well. But Kaiwu really getting the worst of it by the looks of the wind direction here. So watch out for the VOG. It's certainly our biggest impact. We've been seeing reports come in for a while. We do have the State of Hawaii air quality data site. Let's see if I can get this to show me some values. There's some. So everything is in the green here, but the values are a little bit higher. This says 33, this says 29. So for example, in Pahala, you can bring up the graph, and even though we're in the green, you can see we've been bordering into the yellow for not just today, but there was yesterday, and there is a day before, and here is a day of the eruption as well. So similar in Naalehu, Ocean View. So you're seeing these signals in the statewide sensors, just not very many sensors across the island. So we do like to go to our Purple Air monitoring network, citizen scientists, which is measuring particulate matter now rather than SO2. But as SO2 is reacting through the atmosphere with water vapor and sunlight and becoming particulate matter, then the PM 2.5 works as a measure of the VOG further away from the source especially. So here it is, and you can see that there are more of these light greens and these yellow colors widespread across the island here. And I just pulled up a site here from, I think this was somewhere Waikoloa area, just to show how, we can make it bigger here, how the values are rising and falling and occasionally peaking into the yellow there and coming back down and back up. So it certainly is localized and variable. That's what we can say here. So still widespread impact from the VOG. However, if we look at a more global scale, at our windy satellite map here, this is projecting to the future, so let's pull it back to now. There's still a little patch of SO2 evident on the satellite. It's a lot smaller than previous eruptions we've seen, likely because the amount of gas coming out is a lot less as is the amount of lava. And it's not really creating any kind of global effect here. Like there's all kinds of other stuff happening, including other volcanoes, like in the Philippines here, that are putting out much stronger signals than ours. So just a little bit of context there. It's not as much as we've had in previous eruptions here. So that will be our gas discussion. We'll move on to some of the visuals now. And in case you didn't catch our update on Monday, or you just like a little refresher, we'll step through a little bit of what actually happened there. And so we do have this first video to show from the USGS pilot, David Okita. He's flying in showing this sequence of the fissure early in eruption here. You can see this segment, long segment active. We have a second segment active right in here. A couple little bursts together there. I believe that's the number 4, so number 3 and number 4 here, 2 fissures still active, right? This one, number 3, was the one that would last the longest, but still out of the 4th one, we're seeing here ongoing activity at this point in time. So this is clearly in daytime, in the morning, after 6 a.m. when the scientists arrive. There is a little bit of other imagery, but by and large, this eruption occurred in a fairly remote area, close in national park, so there are not a lot of other imagery. But I will highlight one that was on Hawaii Tracker here by Kodi Yamaguchi, who in a national park took these telephoto images. And there is that fissure with Mauna Loa foothills behind it there. There's one. Another that shows the USGS helicopter above the fissure there. And one last one there. Just to give you guys a little bit different taste and flavor of this eruption here, since there aren't quite so many visuals. But we will review the USGS ones. So here is the first USGS video we'll play. And you can see a segment of the fissure there. That would be 1. There's 2. 1 and 2 here. So they're no longer active, putting out a lot of gas, and you can see the dark pads of where the lava erupted from them. And then here we come to that most active 3rd one. Still putting out a bunch of fume, like maybe the 3rd one was there, and here's a 4th one perhaps. Either 3 or 4 here, still putting out lava in this latest frame. But only 1 fissure active by this point in time. That matches what the USGS was reporting in some of their captions, that there was only 1 fissure active by 9 a.m. in the morning of the eruption. So, lots of gas coming out right here. You start to see a little bit of the ground cracks. And then we'll turn back and look up the rift here. So USGS was on the ground. Here is a view on the ground panning near that eruption site. And really the dark colored lava is the new material, and all of the light brown is the ash and tephra from previous eruptions, largely blown in this direction from the summit area. So here is the second USGS video as well, that was also from a little earlier in the day. So here you see that 3rd fissure really active. There is a 4th one again. And now we'll go down a rift further and look at the cracks that occurred. And there was cracking in this very same area around here from the January 31st intrusion. And there was more cracking that occurred as a result of this most recent eruption here as well. But you can see it's a little ways past the lava when flying for a while here, and past the fissure. You see a monitoring station down here. And then a big crack. And then USGS has reported in their captions the widest crack in this area is about 2 meters wide, around 6 feet wide. So that's what we're looking at right in there, is likely a 6 foot wide crack. And you can see that's just the biggest one. It's one of a whole series of parallel cracks and getting pretty deep in there. So for all this cracking to occur downrift of the eruption site, that's likely showing magma moving underneath this very area right here, even though it didn't actually erupt there. So that was that other video, and We'll show you just this last image here where you can see from the top. There's 1, there's 2, there's 3, and there's 4. Looks like 4 was the one that was active the latest and longest. There. There are some new images that have come out as well in this new image release on June 3rd. And we'll just go through one at a time here. The USGS gas team was out, not right next to the fissure, but slightly further back where they could catch the entire gas plume and measure that through their really fancy instruments here. So they're using all kinds of different things, including Fourier transfer, FTIR, we'll call it. I'll leave it at that, so not to complicate matters here. There, that's one of the scientists looking through the viewfinder there. And then here is a further away shot of this eruption. This is one of the more interesting ones to me, because not only do we see lava coming out of the fissure on the left side here, but on the right side, you see some dark colored ash getting blown out of there. So that might have been some, I haven't heard anyone describe any kind of minor explosive activity, but it's getting bordering on that. Right? So you're seeing a mix of white fume there, likely water vapor, steam. The bluish stuff is usually more of the SO2, but then you're also getting a dark material. So this is interesting. And one thing we've heard mentioned is that the lava that came out was more pasty. And what they're meaning by that is the lava looked like it was the older, stickier lava that wasn't moving as fluidly. Similar to the first thing we see flushed out in 2018 in Leilani States. And as we see in many eruptions, the first stuff come out as some of the older stuff. So I'll pause here, and I see Dane, maybe you want to add something here. What does this remind you of? What does this view remind you of in comparison to 2018?
Yeah, so to me, I really don't like the dark stuff when it starts getting those dark colors, because to me, dark colors are synonymous with houses on fire. In this instance, it doesn't look like that, and obviously not that, but yeah, I don't know. I was just wondering if there's like, as it cracks out, if it's all that tephra that we were hearing about being exposed and deposited from underneath could have like cracked and fell in and then gotten blown out of it somehow, like as it's all, the whole area is quaking and shaking apart. Yeah. So I'm just thinking maybe there's some dynamic like that at play, but I don't know. That's interesting, that blacker smoke.
Yeah, I mean, so it could be that, right? Because you gotta imagine even underneath all this lava that's on the ground there's layers of this wind-blown material. Yeah, right. That's all throughout there. But the other thing is that when you have the volcano slightly more explosive, right? The thing that reminds me of a little bit more is like some of the downrift fissures. Maybe not exactly fissure 17, but there was a time when fissure 17 was putting out lava on its downhill side, and it was putting out the steam blast on its uphill side. It reminds me a little bit of that. So maybe you have some groundwater coming in there, and if so, it could be leading a little bit extra of gas pressure to maybe pulverize some of the rocks, whether it's the actual fresh magma or whatever is down there already. And in that case, make that ash that could be very briefly and very locally captured in this photograph here.
Were there any reports of auditory explosions, those pops, those bangs?
Not that I've heard, but that's that, you know, the fissure 17 was really an extreme case. That was shooting 1,000 feet in the air. If this is only shooting 100, and I wouldn't expect that really, right?
Okay.
Sometimes just like a regular vent moving, just when a vent was just going like that kind of thing, that could be enough to be breaking any rock that's falling in there or pulverizing it. Especially if the lava is stickier, right? That means it's capturing more gas and it's able to like burst with more of a pop, if that makes sense. Yeah, so fascinating. There's a little bit more zoomed in. And it's the only one image, and we'll maybe hear more about this in the future. But that's a little interesting thread to pull on here in the future.
I feel like that's the one that you could learn a lot more from it being just a short video if it wasn't a still image. Just to see how that is moving. Is it moving like it was exploded, or is it just wafting, wave in the... It's so hard to tell with just a photo, but it does look like there is some kind of pop in there.
Yeah, I mean, you see that one part of the
Yeah.
cloud is a little darker than the other part of the cloud, right? So that's what makes me think that.
Yeah.
But in any case, we'll look forward to hearing more about that. Yeah, the teaser, and maybe they'll have more videos and images coming out too, past this first burst. Because you imagine the geologists are snapping pictures and then turning to look at the instrument and push a recording button and writing something down and then talking on a radio and then deploying. They may not have time to have uploaded all the pictures or even catalog them at this point yet. So we'll see. But there are more. Here is a similar to Cody's image of the helicopter above the fissure. This is a USGS image from the gas team. And there they are, treated to a rainbow that seems to end right over that dark cloud over the eruption site there. See clearly an early sunrise with the long shadows there. Cool to see. All right, a little closer to the site. Geologists are also on the ground there, and this looks like it might be either a camera or web camera or some kind of tripod-mounted instrument here that is going to be deployed. We have geologists walking along the edge of the flow. So as we showed you guys earlier, there's the flow is not very thick. It's shorter than the person at every point where you can see it. And this is interesting. You see these big clots of spatter that are all off to the side of the flow here. Right? So there's the fuming vent right in there. And in this particular location, you can see that there was more spatter than there was actually flow. And the flow came just a little ways from the source, and it could have easily kept going and buried all this material. But instead, the spatter can only get thrown so far. Right? Usually can't throw spatter as far as you can send a lava flow. But in this case, the flow was so small that you can still see spatter all over the place, all around here. It's easy to sample it to then see what magma that actually was. So there's a geologist taking a sample of some of that spatter there and give you some idea for scale of the size of that flow there. So one thing that you can maybe see is what this pasty character of the flow that they're describing as well. So as well, we have extra pictures of the ground cracking that occurred. So here it is, where we are looking down a rift, and lots of cracks all across the area there. So there might be one or two other images here. Let's see if I can get them pulled up. Yeah. So there is a geologist looking through a hand lens at some of those crystals, olivine crystals within the lava flow. So they're, I'm sure, eagerly looking forward to the analysis and results of this rocks and this chemistry, because it does seem that this area that lava erupted was the same area where magma might have been stored in the end of the January intrusion. So this might have been the magma from January sitting in the ground for 4 or 5 months, cooling, growing crystals, and then flushed out by the pressure from behind it just this week. So here we have that one. Here is another one that maybe shows a little bit more clearly the height of that flow. Right there. So it might be 3-4 feet thick. You may be approaching 5 in some areas, but overall it's a fairly thin flow. And you can see it didn't run very far. It's piling up on itself right here on the edge. And one more. Here's the gas team once again looking through the gas measurement instrument here, and another one looking through a laser rangefinder to measure the length of the fissure and the height of the fountains. So clearly it was an all hands on deck situation. They clearly saw this coming the day before. So we'll describe that when we get into the monitoring signals here, but that is our visual observations from this eruption. And with that, we'll turn back to some of our maps and look at the maps as the next phase of our coverage here. So we've shown this original map. You can see that the fissure line is just in between a 74 and a 71 eruption. Pu'ukoʻe is this cinder cone over here, right along the Maunaiki trail. And this is an area that was documented with lots of ground cracks after January. So we were seeing them intersect this trail and run off into the distance. I'm not sure quite how far, but very conceivably they could have come into the same area. We saw these fissures erupting here. So that's the overall location of it. We'll dive into a little bit more. For starters, the location of these fissures is very near the 74 fissures. If I were to sketch them in, it'd probably be something like this down in here in 74. It's a bad sketch, so rather than that, I will show you the image of the actual fissures. It's kind of tilted to the side here, but there it is. So north is now that way. And labeled A through I are the fissures of the 74 eruption. So it began in an uphill part, A, B, C, D, E, bounced back and forth a little bit before jumping downrift, F, G, H, I, right through there. Right? So if you're looking, there is that little, almost like the boot of this flow right there. I is right above that. And that boot of the flow is down here. So I would be down here. A through E is all up here. So very near, not exactly in the same spot, but very near the 74 fissures. But not only that, the actual direction of the vents, if you look at it, is the same as the 74. So this is a schematic diagram of the rift zones and the fault zones near the summit. The southwest rift generally has these fractures that tend in the southwest direction there, more like that. Whereas the Koaʻe Fault system here is more in a west-southwest direction, slightly a different angle there, right? You see how these are coming together right here. So the point being that in 74, these vents, individually segmented, are actually paralleling the Koaʻe Fault system. But they're in this transition, they're trying to step over, so that overall, if you were to draw from the start to finish the line, it's actually a little bit higher of an angle, trying to approach the southwest rift angle here. And that's the same as we see here. These faults are having that same orientation of the Koaʻe right there. And there's a Koaʻe faults and imagery. And so you see that's the path of the cracks. And we have reports that the cracks came within 500 meters. That's that far from Maunaiki. So right into here, the cracks came all the way down into here from that same area. So more or less like that. That's parallel to this Koaʻe structure here. Right, kind of getting in between there, right, where it's actually bridging the 74 area to the 71 area by going across there. So magma likely came all the way through there, at least into here, and we'll look at that a little more closely in a few minutes here. Okay, so stepping back in time, this was our INSAR from April to May 5th from the USGS. And the thing I wanted to point out here, besides the rainbow of inflation, is this label that there is actually fault movement. You can see how this fringe that comes around actually gets deflected right there. So right there is that fault. And they're showing that the faults were actually moving. So we knew the ground was moving significantly as magma was pressurizing this area for the last few weeks and few months. And so to see the faults moving further to allow magma out of the ground is not that far of a stretch. So, all right, let's come to that next map back from USGS. This is the one from January and February, just showing exactly where that intrusion occurred. And notably, in January and February, we had all these earthquakes moving all the way down with this intrusion. And this time they were missing for the large part, likely because this particular event had opened that pathway and did all the work to allow the magma to move in this time without any seismicity. So the dike opened right around Puʻukoʻe, right there. And that's the span of major ground adjustment across that southwest rift from January. So if we compare that to this one, maybe slightly off as far as up and down rift, but if you consider this just to be the leakage and the actual main intrusion to continue all the way down to here, then it matches up quite well with that area that was previously intruded in late January. Okay, so that was this one, and moving on, another image similar to that showing that fault zone and opening. And in between right here, this zone of subsidence, we had this question come up last week about maybe there was some kind of graben. Here's an actual image of a graben on this imagery from late January, showing how as this thing moved apart to both sides of the arrow there, the part in the middle kind of sank in, like a keystone just dropped in there. So that could well be related to what we're seeing happening now too. Like this zone of subsidence, and the whole block was loose and wiggling, and so now magma came back through, pushed it, and squirted out the edge of the crack of the thing. Perhaps might be one possibility of how it worked. So there is also a more detailed map. This is now the USGS preliminary eruption map, hosted by GIS. So it actually goes to the whole island and shows the most recent flows. There's Mauna Loa's most recent eruption, 2022. Here's Kilauea's most recent summit footprint. And in comparison, there is our Southwest Rift eruption from this week. So zooming in more closely, there's our 4 fissure segments. It looks like there is 2 big pads of lava, but there is actually, in fact, a third. If I zoom way into this one over here, you'll note there's a small pad of lava right in the center of that thing right there. But when you zoom it out, it kind of disappears in there. And there's a second segment, and third and fourth form a combined pad of lava here in a downhill area. So that's where it sits. Did not run very far, obviously. And one last one to show you guys is this map, which is the thermal maps of the Southwest Rift eruption that were just released. So there are 2 images shown here. One is June 3rd, 6 a.m. The second is June 4th, 12 p.m. But they note here that the lava actually stopped moving at 9 a.m. on the 3rd, but they didn't fly over again until the next day. Right, so think of it as 6 a.m. and 9 a.m. And mostly you're going to see the difference in the flow down here, right through there, and different colors of heat intensity in the fissure. So push this through. Right? There's that first image right there, just capturing the second and third and fourth fissure areas. They didn't quite catch this one, slightly uphill. But by the second frame, when I do catch the second, or the flow moving to the south here, with extra expansion, they do expand the field of view further northeast and do catch these extra cracks over here. And so here they are. That's likely that little pad of lava likely came from right in there, I'm going to guess. Which you can see that there is a hot crack going quite a ways up here, right, all the way up through here, which is fascinating. If you think back to we won't go into too much detail today of the 71 and 74 eruptions, but they describe actually seeing the ground cracks opening and then looking down and seeing magma in the cracks, looking like magma was trying to rise to the surface. And as it was trying to come up, the crack would open more and it would just move downhill, and it just follow the crack down the hill. For days and days and days, they saw this happening. So really interesting character of eruptions in the Southwest Rift, where we have this interaction of cracks, almost like a cracks, like some kind of lava tube or pathway, right? Where lava is just flowing through there, and it's venting out. And you can see it moving, but it's not forced up and out because it still has plenty of room downhill in a crack to fill, and it's not pressurized to pop out the top. Yeah. With the exception of perhaps this burst we saw, like maybe you have an extra pulse of gas coming through there, and the extra gassy lava, maybe that's the part that pulses and out through the cracks and makes its way out. So that is the imagery and the maps we have to share at the moment. And with that, we will go into a little bit more of the updates. So I mentioned earlier that the USGS update says that we're not erupting, that the eruption remains paused. And this is today's update here. Tremor, degassing, and incandescence are still present, but have decreased significantly since June 3rd, making it unlikely that this eruption will restart. Gas emissions above background levels. Seismicity overall is low, and inflation continues. That's the long and short here. And so we'll get into a little bit more details, but this is the most current information. So I'll start here at the back, and then we'll rewind a bit. Lava stopped erupting at approximately 9 a.m., and lava flow stagnated by noon of that day. It covered about 90 acres. That's 350,000 square meters, a relatively small area. And glow was still observed, as you guys saw in our summary through the time lapses there. Gas emissions are above background levels, which would be 100 tons, so it's above 100, they're saying. It began at 12 to 15,000 tons on the first day. It dropped to 5,500 tons on the second day. And emissions are much lower today compared to previous days, with precise measurements being made by field crews at the time of the report. Numerous ground cracks have formed in the vicinity of eruption, extending westward to within 500 meters of Maunaiki. Earthquake activity remains low in the eruption site area. Some resources here that we've been sharing with you guys. They mention still low seismicity here, mostly below the caldera. No activity in the lower east rift zone. Everything is contained within the upper rift zones and summit area. And then we have a little bit more refined summary of the eruption. They are saying that this is back to Sunday, June 2nd, around noon, was when this whole crisis began, with the emplacement of a dike, a magmatic dike. That just means a blade of lava. Once there's like some subvertical crack and the magma is just forcing its way in there, pushing its way and pressurizing and moving through there. That's when they saw the earthquakes intensify, and HVO raised the alert levels from advisory /yellow to watch /orange as they saw that dike getting closer to the surface. So 8 hours later, around 8 p.m. that evening, Sunday evening, a strong deflation signal, not only at the summit, but at the sandhill tilt meter, showed that magma was moving somewhere else, even though there was a lack of seismicity. And at first, when I see the Halemaʻumaʻu signal deflating, I say, okay, it's leaving the summit. It could be going to South Caldera. Then you go to the Sandhill station, see South Caldera is also leaving there, and then you have to presume it's going further down the southwest rift at that point. Right, so that's similar to what we saw back in January. And in January, there was a huge mass of magma that did not erupt. So there was some doubt that this would actually pop out, right? But with a caveat that the ground had been already cracked. Now we know in hindsight from the January event, and that probably helped a lot to get magma out of the ground this time, even with less volume and less pressure. So let's see here. After the deflationary event, seismicity declined significantly, and it was no longer possible to track the underground location of the magma. So even though it was moving out, you couldn't tell to where, especially from the public data that was online. Right? Perhaps some of the temporary GPS and other instruments maybe gave them more of a clue within the observatory. But from our end, in the middle of the night, there was nothing to do except wait and see where it popped out, or if it did pop out at all. So they did note webcams and Keck Observatory webcams from the Maunaiki observatories here determined eruption began at 12:30 a.m. on June 3rd. Vents remained active until approximately 9 a.m., and lava flows were sluggishly moving until around noon. So they do note here, additional pulses of seismicity and deformation could result in new eruptive episodes within the area or elsewhere on the southwest rift zone. Right, they're saying quite a lot in all of this here. One thing that we've heard Dr. Ken Han say in interviews is that the character of eruptions may be more pulsing now, right? They're coming in cycles of extra strong pulses, and then not quite as strong, and an extra strong pulse, and then not as strong. And so this is putting extra pressure in our system. And when it's doing that, and then you have areas of the ground that are cracked, like we're seeing post-January, and we're seeing still today now, the ground is extra weak downrift of here. So another pulse that came through could flush stuff out and do it again, is what they're saying. Right? We're not out of the woods as far as that goes, because we're seeing the volcano pulsing every few weeks here, and sometimes every few days. We'll see if it can handle it or not. It's handled a lot for a long time until just now, and now it's a whole new prognosis. Something to add, Dane? No, I can't hear you.
Sorry about that. I was just going through the new volcano watch came out as we were live, so I was just checking it out as we were doing all this. But yeah, I mean, interesting sequence up there. The USGS webcams and the Keck Observatory cams, as well as the story of the volcano house night manager seeing the glow and sending photos to USGS. You know, it's, as Ken said, it was a sneaky little eruption. Ken Hahn, when he was doing his interviews. But yeah, again, this is the volcano watch. It is relevant.
All right, since you brought it up, I'll have to try to read it here real quick live.
Yeah, sorry about that.
Since this was a late release today, it didn't make it into our production. But they're talking about earthquakes giving insight into the eruption here. So they've been monitoring pulses of heightened seismic activity for weeks here. They're noting that there are 2 distinct clusters of earthquakes at Kilauea during the 4 recent time periods. South Caldera cluster, Upper East Rift cluster here. You can see them flaring off here. And that was true in the previous 3 panels. Yeah, and then just in the last few days prior to our eruption, we saw the East Rift cluster decrease and the South Caldera cluster increase. Yeah. So that's what I see there. Those are the 3 distinct periods of unrest there that they're noting. And what they're saying is that they're different storage regions, right? So the different storage regions is as magma is moving from one area and pressurizing one zone, maybe it then can cascade pressure into a different area, and then that one fills and it cascades back. So we've been tracking this for a while, how the center of inflation has been moving around north and south. Describe the wiggly tooth, a piece of land in the middle that keeps moving back and forth. That's the same story as they're telling here. So one thing that is interesting about this context is the intrusion in late January was really not the start of all this. We can go all the way back to August of 2021. We've talked about this previously as well, when we saw that distinct shift in intrusion that first popped into the Southwest Rift. Right. So we'll dive more into that in the future here. We can also have time to compare to 71 and 74. But for now, we'll just leave the volcano watch here and note those connections and let you go check it out on your own. Okay, let me figure out where I was here.
I'll drop a link for that in the chat. Just give me a second to grab it.
All right, so they note in their analysis here, the last eruption occurred December 74 and very near the same area. That eruption was 6 hours and erupted 10 million cubic meters, or 13 million cubic yards. That covered 3 square miles, 7 square kilometers. So in contrast, our eruption was much shorter. I'm sorry, it was a little bit longer, 8.5 hours, but put out a lot lower amount of lava, about 1% of the volume, and only 1/3 of a square mile. So about 1/10 of the area and 1/10 of the volume there. Okay, that's the update from today, the most recent one. But to kind of step through how we got here, I won't go into super detail on all of these. We'll just highlight what we need. But on Sunday at 11 p.m. was when the USGS raised the alert level from advisory yellow to watch orange. That was the first step, as we've described here. And then we have the next morning at 2 a.m., the announcement of an eruption ongoing that had begun at 12:30 a.m. And then we have, let's see here, that same morning, 8:30 in the morning after that main pulse. So we're getting towards the end of the eruption. Remember, they're saying that fissures stopped erupting at 9. So half hour before that, they note that the location is remote, the volume is low, and there is no threat to anyone around there. So they then lower the alert level from warning to watch and red back to orange. And so that all happened pretty quickly, all in 2 days. We go from yellow to orange to red back to orange. And the second yellow came back, I want to say it was yesterday. But we'll get to that here in a minute. On a Monday at 9:30 a.m., an hour after that alert, there's another update put out. They note a few other details. The fissure is approximately 0.6 miles in length. One fissure was currently active, 3 inactive last night, but no longer active by 9:30 in the morning. Flows are thin and have only traveled a few hundred yards from the fissures. Let's see if there's anything else to highlight here. They note the number of earthquakes, the tilting sequence that occurred, the restriction of the location to the summit and upper rift zones, and some of the history of buildup in the area that led to this. Let's keep it moving to Tuesday morning, by which point the volcano was not erupting. They are still calling it at a pause at this point in time, saying that levels of unrest remain high because the vents remain open, tremor is still present, glow could be seen overnight, and active degassing of SO2 is still occurring from the fissures and blowing downwind. And so the hole is basically open. And this is an interesting thing because if you're seeing tremor, the magma is flowing. They're looking in a crack and seeing it flowing. And so they know it's going down the rift to where all those cracks are. And so you can imagine that they would probably be a little apprehensive in calling the thing over when they see a 6-foot wide crack just down where the magma is going, and they've seen the pressure of it. And that's why in some of these updates, they say that it's possible that the eruption could continue further down rift with a next pulse, or from the very lowermost rift, right, that number 4. And so that was Tuesday morning, Tuesday afternoon. They see that we have a new SO2 rate, and we see that everything is in the decrease, but still because of all the disruption of that area, there is potential for more activity. Here it says, the large crack system that developed since the eruption onset extends well past the westernmost active fissure, indicating that magma has been in place at shallow depths beneath the surface all the way to the east side of Maunaiki. While the eruption yesterday occurred due to the intrusion of new magma, it occurred in the vicinity of the dike that formed close to the surface on January. The input of newer, hotter magma could destabilize the stored magma. While the current eruption may be over, it is equally likely that it might resume at or to the west of the last active fissure. So that is explaining where they're coming from there, right? They're seeing huge cracks, magma moving underground through the vents, and will it find a spot where it can stay happily underground, or will it be forced up again? And it seems like the answer is, for now, it's happy wherever it went down rift. But any further pulse now has extra weak ground in the same area, has extra open vents now that we've made a tear to the surface, and an open pathway that doesn't even quake when a magma is moving through it at pressure. All those things together are why it seems like it's equally likely that it could resume, and if it does so, it would be at or to the west right? So overall, my personal gut hunch there is I always try to track the gas. We don't have a whole lot of gas data here, but what they say today, the gas emissions have gone way, way down. That to me is one of the stronger indications that it may in fact not resume, because the gas stopped coming out. That means the fresh magma stopped coming in. Now it can start cooling and hardening and encasing itself, and the longer that goes on, the better chance it has to survive the next disruption. Okay, so we're getting current here. There were updates also yesterday. So yesterday was the day where we went from advisory, or from orange watch to advisory yellow at 10 a.m. That's mostly what I'm noting here. And then coming to what we noted for today's update here as well. Looking at some of our signals here, let me come to the top. Kilauea's last week. Here is the tilt signal, and this showing the complexity of what was going on. There was an initial deflation event that began, was pretty steep. Then we see it pop up, deflate, and it starts wiggling. Lots of earthquakes happening. Clearly things are being disrupted. It's injecting, it's draining out, and finally things stabilize right in here, where that's the draining of magma into the southwest rift. This is basically like an intrusion happening. When Dave and I were talking earlier, he called it a failed intrusion. That's not a bad way to think of it, I don't think. Mostly was trying to make an intrusion, but a little bit of it failed and actually leaked out onto the ground, onto the surface of the ground here as an eruption. But a lot of the work happening underground. I wanted to put this in our 1 week lava summit depth, because in January, we actually saw the crater floor had bulged upwards. And without having reviewed webcam imagery, we have the lava rangefinder depth as a proxy here. So for now, we can look at this, and maybe it bulged somewhere more localized, but it does not seem like it bulged at all. Ultimately, this is the window right through here, right, that we're looking at disruption, and there's really nothing obvious happening. We're so zoomed in here, we're looking at the little micro changes as the ground is slightly wiggling up and down there, but nothing major and like a big fresh batch of magma coming in. So, which is supported by the fact there were so few earthquakes in the southwest rift when it actually pulsed into there. Earthquake counts over 400 in the map area on that one day on Monday, and you see not a whole lot. I'm sorry, actually this was on Sunday, and not a whole lot on Monday once the vent actually opens up. Low levels since then, but it's picking up a little bit here, actually. Picking up more quickly than some eruptions. It may actually be quiet for longer. So depth versus time, not much happening in the Pipahala zone. It's all in a shallow. Here is our escalation right here. Eruption happens here. And you'll note that earthquakes are not quiet. There actually are still some flurries ongoing. So magma is still coming in. It's still moving around. It's still pressurizing and trying to go places down in there. And looking at the map for the last week, it's showing some interesting distribution here. There's also a lot going on here. So let's walk through here, colored by depth. The blue ones are the deep Pipahala ones, but there are a couple of deep earthquakes underneath the summit area of Kilauea as well. We have the south flank, which has this background movement all the time, but there's an extra flare-up that occurred following this intrusion and eruption that culminated in a magnitude 3.4 earthquake earlier today. We'll come across that here in a few minutes too. So the south flank is moving. The intrusion site itself, let's go to that next, is over here. Intrusion, I keep calling intrusion and eruption. Eruption was occurring probably right in here. So you see a little bit of a pathway of earthquakes coming down that way, a typical gap. But we also had earthquakes occurring downrift of the eruption site. So this is near Maunaiki. The eruption happens right in here. Magma is moving underneath there and actually causing earthquakes where it's collecting down at the bottom of the crack, way over here. But that seems to have stopped as well. But interesting, if you note that this pattern, this trend, go there to there, is actually following this Koaʻe trend, fault zone right through there as well. And even we have a big South Caldera cluster right in here, but it also has an arm that goes off in this direction, which then bends to the upper East Rift connector right there before the East Rift bends again here, right? So that looks like it's almost like a continuation of that same structure. So it seems like that whole piece of land this way is what got shoved to the side. Much of that crack allows magma to move as far as here, but it doesn't all make it there without some actually bursting to the surface right in here. So that's a little bit of the what appears to be the earthquake story at this early point. In cross-section, you don't see any of that detail, of course. We'll keep moving. So within the last month, we had quite a lot of inflation building up to this big deflation. You can see we've deflated a fair amount, but we're actually not that far off where we were before, right? We're actually still, even after all of that, at a higher state of ground tilt than a month ago. It's still a net positive here. So while the volcano did some work, it didn't do as much work as we might imagine, considering lava came out of the ground compared to the intrusion we had earlier in the year. There's a sand hill, and as we mentioned before, that's the important factor there. We do see the Halemaʻumaʻu signal on a blue line rising, but much more quickly is the South Caldera line, which seems to be recovering fairly quickly here, right? That's the shove upwards, the decrease, the release following the draining of magma to the eruption site, and very temporary relief because here after less than a day, it's once again inflating. It's inflating at a higher rate than it was before. So would not be surprised if there is more to come, another pulse of earthquakes or movement of the ground. We'll see. Have my doubts whether lava will come out again, but the adjustments underground are definitely still ongoing. Lava depth for the last month, just in case those little wiggles were throwing anyone off. Here we have it zoomed way out. So it's flat, nothing has changed as far as lava depth in the last month there. And I'll just keep going past the earthquakes. Here are the earthquakes from Sunday. They exceed our previous 2 cycles here, but not quite as high as what we had back in January. Now earthquakes per week. This was a January event. This was our cycle here at the end of April, beginning of May. And what we're coming up to now is going to be this little dot right over here, this little bar, very far right. So there were earthquakes for sure, but they were a lot less than the previous iterations of intrusion into the Southwest Rift. There's a 5-year count, and overall, here is our phase from October. It's that July, August, September, October, right there, to now. That's the whole phase of Southwest Rift action, right? With really the change going all the way back to August 2021, when we saw the first intrusion into that Southwest Rift connector. So those are the earthquake graphs. We see GPS, the north-south distance across the caldera, which has been expanding. And we talked about how it expand more when it's expanding within Halemaʻumaʻu and a little bit less when it would move to the south. More in Halemaʻumaʻu, less to the south. And now we see it contracting once again. So either the focus is shifting back to the south, or you're seeing the result of a net loss of magma from the summit into the system, or some combination of both there. Down at Pu'o'o on the East Rift, there is no signal whatsoever, so not affected at all by this Southwest Rift event. In a little more detail, I thought it'd be useful to go through our GPS, 2-year GPS. And now we have twice the distance, so everything is squished further together. Our data is a lot more scrunched to the right edge of the graph, right in here, almost always. And we have an east-west panel on top, we have a north-south panel in the middle, and an up-down on the bottom. And so often up-down is one of the key ones. So you see that up at the summit, Uakahuna is dropping down, Byron's Ledge is dropping down, the crater rim area over here, dropping down, and the southwest at the outlet also dropping down. And you can note that actually before it began this little drop, it actually had stopped rising and stabilized before this eruption, maybe reflecting that pressure that had grown and that something was going to have to happen to accommodate that pressure. But you can see that besides just these down drops, there is quite a bit of a signal coming in as well. The outlet station shifts significantly northwest when this pulse comes through. Crater rim, it moves also to the west and to the north while dropping down. Looking at the southwest rift itself, at Cone Peak, we have a pretty big westward, northwest motion right there as well. In that case, it's actually getting popped upwards. So now we are closer to the site of intrusion and eruption, but the ground is moving a good amount there as well. And for comparison, this was right here, the January event. So in this area, you see it got shifted to the north. It got shifted to the north about just as much as it did last time here as well at Cone Peak, which is only a mile and a half from the summit. A little further from the summit, KLSM. Here you see a big jump to the west and to the south, southwest, and down, right? Which is interesting because this particular station in January actually moved northeast. And so now it's moving the opposite direction. So the station's in one spot. In January, the magma comes on one side of it, and now it came on the other side of it. So that's showing different direction of motion. Right, and showing how close everything is in there. That's the southwest rift stations to highlight. Over here at Ahua, which is that closest station south of the summit caldera area in the Koaʻe region, south flank area, we have a massive jump to the east and south, while also popping up a little bit. We go further to the East Rift connector area, Middle East Rift Zone. We're seeing some changes, but much more subtle. A slight shift to the north. Right there is all I see at Puhimau. Devil's Throat. Slight shift to the east only. Over Kalapana Trail, that was getting pushed east a little bit quickly. That seems to have relaxed. That's about it. Makapui, similar, a little relaxation of the eastward push. Ainaho is not giving enough data. Halemaʻumaʻu is down all the way at the coastline on the southwest rift. And so here's an interesting thing to start looking at. Here's January, when a pulse actually occurred. And if you recall, the earthquakes in January moved down the rift over a series of a couple of days. So it wasn't an exact first day of this intrusion. It was more in the following days at the beginning of February that we see this most downrift station showing this big southward push because magma was wedging in uphill of it to push it to the south. This time, hardly anything down there. So this intrusion did not make it nearly as far as the one in January. Right? Maybe some slight effects from far fields, but nothing major, really. Hinapali is a similar story. Now we're getting further up the rift, closer to the summit, right? That had a massive movement in January, and nothing this time. And Mane, Makukibukanene, had a big drop. We have a little one here, but not nearly to the scale. So all this is hopefully adding up to show you that this was not nearly as widespread and as big an event as we had in January, even though this time it erupted and last time it didn't. Yeah, and so that's the things to highlight. On the East Rift, down at Kananuyohamo, down at Kamoamoa, down at Pu'o'o and Jacuzzi by there as well, down at Jonica, maybe some little wiggles here and there, but overall everything is still sagging and adjusting to all the action happening west towards Kilauea Summit. So that is our GPS there. I want to just end the monitoring signals by just recalling this old graphic here, which was these authors were trying to calculate how much magma was coming in the volcano at the summit and going to the southwest rift and the southeast rift and erupting at either place versus being stored underground. So I'm focusing just on the southwest rift today. And what I want to focus on in particular is this era of 74 to 70, when there was two eruptions, the 71 and 74 eruptions both, right? So what this is saying is magma is coming to the volcano at some big rate, 400 million cubic meters there. Some is coming out at the top, filling the magma reservoirs under the summit. Some in this case is going to the East Rift. All that's great. What we're going to concern ourselves with is between 71 and 74, 2 southwest eruptions captured on here. Here is what went in there. 100 million cubic meters went into the rift zone. Of those, 10 made it out as eruption, 90 stayed underground. So what's normal in the southwest rift area is this proportion, that 90% of the magma stays underground. So as we recall all these signals and look at the pattern of GPS stations, things moving around, look at how much lava leaked out compared to how much the ground actually moved. I haven't heard a volume yet, a model for how much magma intruded underground to cause the displacement that we saw. We recall that in January it was 30 million cubic meters. And in contrast, what came out of the ground this last eruption was 0.1 to 0.4 million cubic meters. So tiny, tiny amounts. And most of it, I expect, is underground in those cracks. And we will await a number from the USGS once they do all the calculations of how much actually went in there and what proportion of it actually came out. And it may be less than 10% even of what actually came out of the ground here for this eruption. Okay, that's a lot of data, a lot of monitoring signals. So we'll just try to go through some earthquakes fairly quickly here. Here's the last 2 days. So showing what's going on presently now, colored by depth. So without anything notable elsewhere, there is our still ongoing or resumed summit earthquakes. Yeah, there's a magnitude 2, 1.9, 2.3. Down here, we have the 3.4 from 12:30 today, at a depth of about 1 mile. This is that adjustment of the south flank to the Koaʻe intrusion area. Okay, let's look at our earthquake filters. Let's go back to the last 2 weeks and come down here. You can see that full pattern of it. And so there's that south caldera line, and notice how, if I zoom in here, you're not seeing a connection on this upper east rift connector coming from the summit. You're seeing it come from the south caldera sideways over there. That's that little bend I was showing before. That's fascinating. It seems like the source really is building up through here, and it's found one of these cracks to then pressurize this whole area. But also this one coming this way. Our eruption site is right between a 74 and 71 sites. So that is 74, that is 71. So right in here somewhere. And those cracks that went underground came all the way towards Maunaiki. And here is that cluster of shallow earthquakes, likely near the end of where that magma was accumulating by Maunaiki. Maunaiki is an old, long-lasting eruption site. So you likely have some harder rocks blocking paths underground there. It's probably not as easy to crack through this as some other parts of the landscape around here. So really fascinating stuff. That seems to have slowed down by now, as you can tell. But this is giving you a little bit more of the picture, full picture of what happened here. Over here to the side, Mauna Loa summit, a couple of earthquakes, but you are noticing also these orange events are often flank depth of Mauna Loa. So Mauna Loa's flank is also adjusting in response to this, to some degree, not in massive amounts, but a little bit. You can see through the earthquake activity. Colored by time now, our largest event's a 3.4 right there. That was today. There's a 3.0 super deep up here in Kohala that may have been felt 62 miles down. That's a random one-off, nothing to worry about there. But otherwise, we're down on the 2s again, and 2.4, 2.3, or the highlights of the summit region before we get down into the Pahala earthquakes down here. So that is all the data for Kilauea we'll share. Quickly touch base on Mauna Loa here, and then we'll do our usual wind-up discussion and wrap-up. And Mauna Loa has an update released today as well, which is much less exciting than Kilauea. It remains at normal and green. The seismicity has been low. everything is as expected following the eruption. There is a very slight inflationary trend near the summit as the volcano recovers and replenishes its magma. That's the Mauna Loa update. But while we're here, Kīlauea is also normal and green. Haleakala is also normal and green. Maunaiki is also normal and green. Kamaʻehua Kanaloa, unassigned, not well monitored, but no activity detected in the past month as well. So Kilauea is, as usual, carrying the baton for the whole volcanic islands here. Signals in Mauna Loa. It did pick up all these earthquakes occurring here, but the tilt has not varied drastically, as you can see in the plot here. Very few earthquakes over the last week, really over the last month. There's a month tilt with earthquakes being detected, but maybe you see this blue line starts coming up a little faster because of those events, but I'm not so sure about that. But in any case, if there was an effect, it was a small scale and short-lived. That does appear to be the case. For the last month, earthquakes fairly shallow still. Earthquakes per day are still below 4 for that summit region and upper flanks. So very little activity. And this follows the deep earthquakes about a year ago, a little more than a year ago, less than a year ago. That was the most exciting blip that followed the 2022 buildup and eruption. So still recovering, not a lot to share there. GPS is still expanding. North and south is getting further apart. Not rising quite as fast, but it is still generally rising. So magma is still coming into Mauna Loa and building up in there. There's quite a lot of Mauna Loa GPS also, but I'll just scroll through, and if you just look closely, you'll see that there's very few signals coming in at the right side of these. There's one I want to reach to highlight, and then we'll keep it at that, and that would be this one at Ainapua right here. South flank at 5,000 feet. And the reason this one is noteworthy is because you can see in January, it actually did show a signal offset here where it got shoved to the north and to the west as a result of that intrusion. And this time, it is not showing that effect, also showing that it's a much more localized effect to Kilauea and not affecting nearly as far as Mauna Loa or nearly as much as it might have in January. January was really a massive, massive event, a lot of magma, all in a short time, shoving its way in the ground and causing everything to move out of the way. So that is Mauna Loa. And I'll just end on a throwback to the 2022 eruption with this animation by Cosme on Twitter. And he's just, let's see what his caption is here. Enhanced SWIR taken by Copernicus Sentinel-2 on December 1st. So that's just a nice capture of the caldera filled with lava during those first few hours before things migrated off to the south, to the northeast rift right there. So the weather was really bad, and it's taken a while for the processing, but cool to see this and just a little bit of a reminder of what happened last in Mauna Loa. And we're not quite getting the stuff to the south here, but all good. We'll take it as a start. All right, we did the Volcano Observatory. I'll skip to finish up with our community corner. In a national park, the eruption has paused. You cannot see glow or lava, but some people may try. There are gas. Because the gas is still elevated in the area, the closures are still ongoing in the national park. This includes Halemaʻumaʻu Road, the campground out there, Pipeiao Cabin, and Maunaiki Trail. Right. Some of the previous reports also suggested that the Ka'u Desert pull-off was also blocked off on Highway 11. Previously, the Ka'aha Trail and campground were closed, but now they are announcing that it is open and accessible along the coast on the Puna Coast Trail. So closures are still ongoing there. Not that it matters for most people since you really can't go and see anything anyways, but then these are areas that are further off the main paths of the park as well. All right, that is it. There's a lot more we can talk about. Comparisons to 71, to 74, other things. We'll leave some for the future. Just want to try to catch up here. Now that we have some data coming in, the GPS especially, is nice to have a few days for it to register and correct itself and show us what might be happening over a several day time period rather than minute by minute, hour by hour. So I'll pass it over to you, Dane, for our mahalos.
Yeah, let's go ahead and do those first, and then we'll come back and get some questions. So I'd like to thank, first and foremost, all of the viewers that tuned in today. We rely on viewers like you to help get this information out there. The like, subscriptions, the shares, all that stuff does help with the algorithms. I know you hear it all the time, but it's true. And it gets this content out in front of more people that might want accurate information about the volcano. We also like to thank anybody that makes donations, but we'll come back to that. First, we'd like to thank, though, the County of Hawaii through the Puna Strong and Kilauea Recovery Grant Program to help make this type of content as well as the other things that we do possible. So we appreciate them. And what do you think? We'll do questions, and then we'll go into donation. Thank you. How does that sound?
It's up to you, yeah.
All right.
Any more thank yous? Thank yous?
Well, we're going to have more coming through, but we'll save those and do questions and then bring in Lou and wrap it up that way. Sound good?
All right.
All right. Well, let's start with some questions. First, from Greater Good. Does the pasty or stickier lava have a higher silica content?
It might. It's a good question. Greater Good. It might have a higher silica content. I think we can say that it's more viscous. Can you leave that up there, Dane? Actually, question up there. Yeah. So pasty or stickier is more viscous. So that means it could be more silica. It could have less gas. It could have a cooler temperature. It could have higher crystal content. All those things are possible influences on viscosity. So higher silica might be an answer, but we'll have to wait for the USGS results to know whether that is the case or not. I can say that there are areas downrift of here in the Kamakai'a Hills, I believe, where there are some andesitic basalt eruptions, which is higher silica that are normal lavas. So there are pockets of magma in the area that do evolve and get higher contents of silica. I'm not sure that's what happened here, only because we think it was just from 5 months ago and not beyond that. And that's what I can sure to discuss. I don't have the answer.
All right. Next question will go with Scott, who asks, Aloha, wondering if you think the lava came out of the Southwest Rift because the lava crust over the caldera pit is just too hard and thick to break through right now. This is a common question we get.
Yeah,
it is.
I mean, so the thing, Scott, is that, which is really fascinating, is that in January, and maybe you caught this in our, when did we show that? Maybe 2 weeks ago now on the update, or maybe it was just 1 week ago, but 2 updates ago. In January, we actually saw the crater floor like bulge up. So magma came through the system, popped up into the lava lake underneath the crust, just a little bit, enough to cause that crust to bulge up in one area. But in doing so, it actually pushed sideways into that Southwest Rift corridor because it was actually open already. So I think the crust that's on top at the summit is not too hard and thick to break through. I think the path going to the southwest is probably just more easy to get into. And I think we saw that change occur in January by seeing it bulge up and then stop bulging up and then move on to the southwest and do all that action down there.
It kind of reminds me of what we saw with most recently the Mauna Loa eruption in 2022 with that train wreck of the front leading edge once it got into the flat area. And then it got bigger and bigger and harder to move until the point where it's easier to reset up the hill and have a breakout and a new lava flow than it is to move that giant pile. It's going to take the easiest way wherever that is.
Yeah, and the complication is that all the blocks of ground are all moving around, so the cracks in between them are shifting, and possibly opening. They could be opening because magma is moving into them, or they could be moving because gravity is pulling the south flank down, and that's causing the opening. It's always been our age-old question here in Kilauea: is who's driving the car? Is it gravity pulling the flank, or is it magma pushing its way in and pushing the flank out of the way? And it varies. They take turns, right? And sometimes they're both have their hand on a wheel, so to speak. But it does seem that big intrusion did a lot of work in opening a pathway so that what happened back then did not happen this time, and it went through without having to push upwards, without having to cause extra earthquakes in the Southwest Rift as well. So
the next question, we don't know, really. I'm just going to say that up front. We don't know, but there's an interesting part of the question, so I want to bring it up. All right?
All right.
Dennis asked, does the USGS plan to get a live streaming camera into the area? We don't know. Since it's becoming apparent that the Southwest Rift Zone is going to be the focus of activity. Do you think it is going to be the focus of activity?
Yeah, and I think it's proven to be the weakest link, right? So we talked about following the 2018 collapse, the weakest part of the system most likely to erupt would have been the summit at Halemaʻumaʻu. It had the most cracks, it had the most damage from 2018, and that's what we saw happen. Since then, the last question, it does get it right that the filling of lava in the crater has strengthened the summit to some degree. And so all the extra lava does make it harder for it to come out there than before. And in combination, we have now the weakest part is all the cracks that we just saw form just this week, following the ones we saw form earlier this year. So right now, where are the weakest cracks? They are in the Southwest Rift right now. Does a pathway stay open that magma can keep feeding into there and it can make use of those cracks? Are those cracks, and it not causes eruption? That's one possibility. Are those cracks opening so easily that the flank is moving so well that maybe instead of erupting, you can just keep wedging the magma in there at depth and just keep moving the flank, and maybe you have more gas vents and things, but no lava come out? There's all kinds of things that could potentially happen, and it's a place where we don't have a whole lot of history to go on, right? We have 71, we have 74, we have a lot of stuff that's older that we didn't actually see erupt, so we can analyze where are the flows now, what's the chemistry, how fast did it go, all that. But most of them did not have someone watching them happen, unlike these most recent ones where you really can compare dynamics. So I think it could well be that, right now, the Southwest Rift is dealing the cards, really, right?
All right.
We'll see.
We'll do the last question here from Rappel. Yes. We might want to pull up the Sandhill tilt meter for this one. Why is the green graph of Sandhill tilt higher now after the slight settling of this eruption than it was before this eruption started?
Well, so the simplest answer is the ground is at a higher level of tilt than it was before, even with the eruption, right? And this is the main thing where you might imagine there's possibly more to come. Of all the eruptions we've seen, this one is the one that has done the least work, we'll call it that way, of all the ones as far as of what comes next. So yeah, the ground is at a higher level of tilt than before, and it's actually still rising fairly fast. I think the USGS said it was 9 microradians in the last day of what came up here. So what was the question again?
There you go. Slight settling of this eruption than it was before this eruption started. So that gap up, I think.
Yeah, maybe between here and here, right?
Yeah, the gap.
Yeah. So yeah, there is that. The other thing that I was going to say is that it's hard to tell in here because there's so much stacked on each other. But usually when a vertical line comes up, that's a earthquake shaking instrument back and forth. And there's a lot of them stacked on each other right through this area, right through here. And one thing that can happen is when a ground breaks and it moves, it can move and then come back to where it started, or it can move and just stay moved. Then you actually have an offset, a step on your graph. So that could have been what happened here. It could have been it's actually an offset between here and here. And so when it comes back down, it doesn't look like it's coming back down because it's actually shifted baseline's off. That's one possibility. But it could also be something where it really didn't relieve that much pressure in this area, and the pressure wave swept underneath here to the southwest, and it's still recovering. And really, that's why this part of the graph where it's rising so steep now is what's the most interesting thing, because regardless of what it was down over here, whether it offset or not, this is showing very high recharge to the area. And that's going to either have to stabilize or it's going to cause more issues in weeks to come here.
All right. Well, that does it for questions today. Thank you, Phil, for going through those with us. I think at this point, I will bring on our producer and project manager, Lou, to help us go through and thank all of the people that have helped make this possible. So thank you, Phil, and maybe I'll bring you back in to say goodbyes to everybody at the end. All right. Hey, Lou, how you doing?
Hey, doing good. How's it on your end?
All right. So yeah, you want to lead us through some thank yous here, huh?
Yeah, definitely. I saw Tiggy dropped a $10 super chat, so thank you very much for that, Tiggy. And I want to say thank you to those that have donated in the past week on our donor box. You can reach us there at hveri.org/donate. The best way to send a donation to us and support us. The credits are running. I have updated them today.
So thanks everybody that's contributed. Are you going to read them out? Go for it. Go.
Nope. All right. Thomas, Lisa, Vicky, Gina, Sprout, Queen, Jana, Ackerman, Mary, Tim, Bonnie, Ernesto, Susan, Donna, Michelle, June, Christian, Stephen, Jana, Jane, Joan, Bob, Alice, Charlie, Daisy, Frank, Helen, Ivy, Jack, Vance, Gina, sorry, Vera, sorry, Carrie, Dorothy, Sharon, Milan, Shanta, Carrie.
How do you actually do that?
Because I'm the one who's
sorry,
typing
Carrie.
them all and
sorry.
I'm the one that's typing them all day long.
We get to get both of you on that speed challenge.
I don't know. But if Carrie starts moving that fast, we're going to have to spray her down with biofreeze at the end of the night.
So yeah,
thank you.
Thank everybody. If you would like to support us, the best way to do so is over on hveri.org/donate.
Yes.
Right there.
Also,
and
be sure to go through the webpage. I'm sorry, Dan. Be sure to go through the webpage. There's a lot of volcano education there. Our other programs, the digital resilience networks that we're working on. Go through it and get educated. It's what we're here for. So I just wanted to push that out there. Our new Follow Us page is also on there. I put the link in the chat tonight. Check it out. We're working nonstop to build that website, and we hope you like it. So thanks again, everybody.
All right. Thank you, Lou. Until next week. All right. Welcome back, Phil. I figure we could go ahead and close it out here, huh? I think we've gotten through everything.
Yeah, for sure. Yeah. Thank you guys. I appreciate all those donors. Appreciate the speed reading and speed signing as well.
Fun little segment.
And yeah, that's it for us for this week. Unless something pops up again between now and next week, Thursday, that's when we'll see you again. 5 p.m. Hawaiian time. We'll see what comes of all this activity. If something does occur between now and then, it's maybe a higher chance than usual, then we will pop back in. But otherwise, no one's got anything to worry about with this volcano. Yeah, anything that does occur now, even a reactivation, is not going to cause further threat to people or infrastructure. There's no magma going towards people now, and the worst we might get is some more gas for a while. That's really it. It's still kind of ongoing here. All right, so until next week, from HVERI, it's Dane DuPont. Mahalo to Carrie and Daniel Kaufman, our ASL interpreters. I am geologist Philip Ong. And until next week, aloha.